So if you travel around the world to everywhere except for one other country, or if you're going to be working in science, at some point you're going to be using the metric system. The metric system is something that we're going to be using in chemistry. So what is the metric system? It's just a little bit different than the English system that we use here in the United States. So the metric system has a couple different things that we can measure. Now, these are the four that we're going to be concentrating on during the course of this course, but there are, of course, other items that we can measure. The easiest one is length. That's just simply the distance between 2 points. And we say that the unit of measurement in the metric system is the meter. Volume, that's the amount of space an object takes up. The unit is the liter. Mass is how much matter is on the inside of an object. We say that the unit is the gram. And of course, time we still measure in seconds. Now, we can abbreviate these different systems. So the meters, the liters, the grams, and the seconds. For quick and easy kind of writing in a math problem, we want to use an abbreviation rather than the whole word, meter, liter, gram, or seconds. So we've shortened them down to little m, big L, little g, or little s. The metric system also uses a series of prefixes in front of either meter, liter, gram, or seconds to help kind of multiply them or divide them by 10. And it either enlarges or makes smaller the unit, so it makes it more convenient depending on what we are measuring. These prefixes are mega, kilo, hecto, deca. There's, of course, the base unit system, deci, centi, milli, micro, and nano. And notice there is a 10 to the value. Now, this is what would get multiplied into the base unit to make it representative of that new system. And we would put the prefix out in front of the base unit. Unfortunately, these prefixes and these 10 to the values are something that you're going to need to remember. And I do have a pretty easy way of at least remembering what those prefixes are. I have a sentence that I use that represents every single prefix in this whole pattern. So here are the abbreviations that you would have to remember that go with these. Notice that there's only one that's capitalized, that's the mega, and everything else is shortened down to pretty much one letter except for deca, which is DA. Notice also nano turned into this weird cursive U looking symbol. That's called a mu. It's a Greek letter. The other thing I'd like you to notice is how the tens structure themselves. The base unit is 10 to the 0, and then it goes up by 1 from there until you hit 3, and then it will go up by 3s. That same pattern from 10 to the 0 goes down. It'll go down by 1 until you hit 10 to the negative 3rd, and then it will also go down by 3s, so to the negative 6th, and then to the negative 9th. So here's the sentence that I like to use to keep the metric prefixes in order, and that is, many kids have dates, but don't carry much money now. Now, I like that by the time you hit money, that money symbol is kind of a weird symbol, and so is micro. So that makes it a little bit easier for me to understand and remember. And also, when you start a sentence in writing, you usually capitalize the first word. And mega is the only capitalized unit in this whole system, which is pretty nice. So hopefully that will help you remember these. Again, you do need to memorize both the prefixes and the 10 to the values for them. So when we use metric prefixes, we simply put the prefix next to the base unit that we're modifying. So in this case, I threw meters in. So you can have megameters represented by a certain amount of base unit. Like for example, 1 megameter is going to be the same as 10 to the 6th meters. That's a lot of meters. You could also as easily replace this with liters. So it works with this as well. So for example, take a look at centi, CL. 1 centiliter equals 1/100th, or 10 to the negative 2nd liters. You could also put grams in with this whole scheme as well. For example, 1 kilogram, 1 kg, equals 10 to the 3rd, or 1,000 grams. So I want to make sure that this is absolutely clear. Now, I was just kind of talking through these, but this is exactly how this chart is going to get used as a series of what I like to call equivalence statements. So on the left and on the right, these two things will equal each other. So 1 megagram will equal 10 to the 6th grams. Again, I like to call these things equivalence statements. And that's where two things are equal to each other. They're separated by an equal sign. And we can use equivalence in a very clever way. I'm actually going to take these equivalent statements and I'm going to turn them into a fraction. So I'm going to take 1/2 of the equivalent statement and put it on the top part of my fraction, and the other half of my equivalent statement and put it on the bottom. Now this is pretty arbitrary, so there's two possible orientations of these two fractions. Let's just take, for example, 1 hectogram equals 10 to the 2nd grams and turn that into a series of fractions. So it would be two possible fractions. Well, one fraction would be 1 hg on the top with 10 to the 2nd g on the bottom. And the second fraction would be 10 to the 2nd g divided by 1 hectogram. Now, we can use these later when we're trying to convert amongst all of these metric prefixes. But what's really kind of interesting about the value of these fractions is since that they were made with an equivalent statement, both the top and the bottom, although they don't look mathematically the same, they have the same value. So both of these fractions have an overall value of 1. So when we use these fractions and multiply them into a new number, it doesn't really, in essence, change what the number is measuring. It's just going to change the unit that goes along with that number. And although that might not make a lot of sense in this particular segment of this video series, it will as you move forward into the metric conversion section. But for right now, know that it's possible to take an equivalent statement and turn it into what I call a conversion factor. Now, another thing that we're going to need to remember before we move on to the actual metric conversion section is a rule that's very important when you are multiplying fractions together. As we move forward, we are going to be taking fractions and representing them in this kind of orientation. When I want to multiply two fractions together, instead of actually taking the time to write a times symbol between the two, I'm simply going to separate them by a vertical bar. Now that vertical bar in chemistry means that I'm going to be multiplying these two fractions together, but it's very convenient and very quick to then keep these two fractions separate. Now the specific rule that I was discussing with you about the fractions and why fractions are so important to us in chemistry is the ability to cross off like terms between the top of any fraction and the bottom of any fraction when we're multiplying them together. In this case, I see that I have an m on the top and an m on the bottom. That enables me to cancel out these like terms. That turns this overall problem then into something quite simpler, where anything that's on the top of these fractions would get multiplied together and anything that's on the bottom of these fractions would get divided away. So the overall math problem that results from simplifying and now finally resolving these two fractions together would be this. It would be 2 times 11, because they're on the top, they get multiplied together. Then if you're going straight into the calculator, you would hit divided by 5 since it's on the bottom, but then you also hit divided by 7 because it is also on the bottom. I call this method of converting numbers field goal post converting. You may have also heard this as unit conversion, unit analysis, or dimensional analysis. There are many different terms for this very same concept. For this course, I like to call this field goal post converting. And we're going to apply this again directly when we go on to converting within the metric system.